It gives me great pleasure to introduce Thomas and White, who's going to give a presentation on OpenROV. Thank you very much.
Thanks, Wayne. Everyone hear me all right? I just wanted to say thanks for letting me present here tonight. I'm elated to be talking to this group. I wanted to thank Ryan and Alan for allowing me this opportunity. OpenROV has been a life-changing project for me. It all started, first of all, let me explain OpenROV. OpenROV is an open source robotics project that was invented by Eric Stackpole and David Lang. It's a telerobotics project, so many of you are probably used to using RF or remote controls that transmit a wireless signal to your robot that allows you to control it. The problem we have with that in underwater applications is that RF does not travel more than about 6 inches under the water. So you see a lot of remote control boats and submarines that go on the top of the water. But as soon as they go down very far at all, they start to lose communication, and they can no longer be controlled. The OpenROV uses a 100-meter tether to go underwater up to 100 meters. And it has to have a tether. It cannot be wireless at this time. Another reason for that is so that you don't lose it underwater. So I'll start by telling my story. About 5 years ago, I was in accounting and finance. I worked at Fortune 500 agricultural companies such as Monsanto and Bunge North America. I worked in a beige cube and I stared at spreadsheets all day long. During my lunch breaks, I would go on the internet and look at a website called Boing Boing. Some of you might know who Mark Frauenfelder is. He's some know him as the founder of the Maker movement. When I was going through this blog one day, I noticed an open source project that was at its infancy. The project was OpenROV. When I saw this robot, it reminded me of something I saw as a child on Johnny Quest. If any of you remember Johnny Quest, if anyone watched Hanna-Barbera cartoons in the 70s, everyone knew how to scuba dive. Whether it was Josie and the Pussycats, whether it was the Scooby-Doo gang, Johnny Quest, everyone knew how to scuba dive. On that cartoon, they actually had a small ROV one time that would go down to an underwater habitat where the Dr. Quest would hang out and do their Johnny Quest adventures. When I saw this robot online, it's something that I wanted to build very badly. I've been a scuba diver and a free diver since I was a child, and I spent a lot of time under the water, listening to boats, watching fish, just swimming around, and I'm lucky I'm not drowned, to be quite honest. So when I saw this robot, it's something I knew that I had to do. I immediately downloaded the plans because it's an open source project, and I began work on the thing. In Missouri, there's not a whole lot of laser cutters. There's not a whole lot of Arduinos. There's not a whole lot of BeagleBones or anyone that really knows much about them. So it took me about a year to build this thing. During that time, we got a Kickstarter up, and the people at OpenROV started that Kickstarter, started to raise money. It's during this time that I started my building this robot. The biggest challenge that I had during this time was sourcing the parts. Again, in Missouri, you just can't go to the local tech shop and start building something. The first thing I had to do was just start ordering these things from all over America and hope they would arrive at my house in time to start the build. So the question is, how does an accountant become an engineer? This OpenROV is called the Starfruit Surfrider. It's the very first robot that I ever built. I built this in my little worker space in Missouri. This is one of the first iterations of the OpenROV design. This was a 2.4, which I think the very first design was a 2.3. Up here you can kind of see my workbench. It's very cluttered. You can see the build. The OpenROV uses ESCs, 3 brushless motors, an Arduino controller, and as well as a BeagleBone microcontroller to make it all work. At the time we put this together, we used the BeagleBone White. Now this was the most exciting time for me, is when I first brought up, got the batteries in the robot and turned it on, and we got the cockpit to come up. And that's the first thing that it saw was me working on the thing, and that's my brother standing behind me, kind of skeptical that the whole thing was going to work. Now this video is a video that I made about my journey. This is me leaving Springfield, Missouri to come to California for Maker Faire.
Yeah.
Demo gods are here.
There you go. Any tornadoes on the way?
No, there were no tornadoes. I'm sorry you can't hear the music very well. And the first part of the video is rather boring. It's just me driving out here.
Dinosaur. 8 dinosaurs. You're lost.
Uh-oh.
Where'd the road go?
I'm going to calibrate.
Now I'm going to stop the video right here because this was a defining moment in the journey. I had driven all the way to the Denver Aquarium and found out they wouldn't let me put the robot in the aquarium. But what they told me about was a scuba location in Utah called the Homestead Crater. Has anyone been there? It's a 90-foot big bathtub that goes straight down. It's probably about 20 meters in diameter. And it ended up to be the perfect place to test an ROV, as you will see. It's when I got here and got in the water that I knew my life was about to change. And I camped the whole way. This is the first time I actually tested the thing in the water. Now, I wasn't sure if it was going to work or not. And what was real nice, the whole OpenROV team was watching me travel on the internet as I was making posts, and they were cheering me the whole time.
Is that a flooded cave or an old mine or something?
It's a hot pot. That's what they call a hot pot. It's a geological formation.
No geyser.
And that right there was the moment that my life changed, and I stopped becoming an accountant and I became an engineer. Arriving at Maker Faire. It was my first Maker Faire, and it was one of just the neatest thing that I'd ever seen. Now at this time, I didn't actually have a job at OpenROV yet. I just came here for Maker Faire, and I was supposed to leave after 3 weeks. What year is this? This is 2014. Can you turn it down a bit?
You're a little hard to hear.
We can't hear you over the video sound.
That was actually an OpenROV diving with divers. And this is the inside of a sailboat.
This is a sunken sailboat.
It was sunk at the bottom of Lake Tahoe. All right, that film basically sums up my journey over the last year and how I left the accounting field and became an engineer. I know it's kind of an unlikely story. So, what I wanted to talk about at this talk is the evolution of OpenROV and how rapid iteration can lead to quick design changes and a lot faster evolution of a product. There was a time when to get something designed you had to hire a lot of artists, graphic designers, people with a lot of talent that took a long time to design what you needed to design, and to get an actual working prototype is something that could cost anywhere from $20,000 to hundreds of thousands of dollars for a working prototype. But we started doing things lately with technologies in 3D printing, cheaper CAD software, better CAD software that's easier to use, so that if you're designing something as an engineer, you can create things quickly, you can get results quickly, you can test those results, and then go back to the drawing board and try again. The OpenROV is the epitome of that process and that way of thinking. So, the first design iteration is the Kickstarter, or what we call the 2.3. The Starfruit Surfrider is a good example of that design. This first robot, which you're going to see some of the same parts in this robot that we use in the latest version. Can everyone hear me okay?
Yeah.
Yeah.
Just a
Move it
little
just a
bit.
little.
Yeah, just maybe up a little bit more.
Is that a little better?
I think so.
Maybe a little bit more.
I'm fine here.
How about that?
Can you click something on your column?
Let's try again. How's that? You're a little higher? How about right there? That's good, right?
Yeah.
Okay. The main components of the OpenROV, and this is true just about for every single version, is a controller board that houses ESCs that control your motors and accept commands from a BeagleBone, which actually has the web interface on it that you use to help control the robot. It also
ESC?
electronic speed controller. These are used to send electronic signals to your motors, so that when you try to control the robot, it will actually send those signals to the motor and do what the motor will do what you want. It will spin the direction you want, the speed you want, and have the torque that you want for whatever specific purpose that you're using it for. We also use, in this case, one thing that's stayed true throughout every design is the little HD webcam we have in here. This is about a $30 webcam right now. Every time we try to get a better camera, it ends up costing so much more money. And one of the goals we have with OpenROV is to make this a low-cost robot. The closest thing that you can buy right now that will do what an OpenROV will do is close to $6,000. So what are our competitive advantages is that these are kits that people can build themselves. Kids build these for school, everywhere up to, I mean, we sell these to people at NASA that want to build these. We've had governments buy 10, 15 of them because with a budget of $60,000, you can buy close to 40 of these OpenROVs, or you can buy one ROV that will break down all the time. So that's one of the things that I've liked about this project is that someone like myself who's an accountant that doesn't have a research grant or millions of dollars in the bank can build an ROV that actually works. So this is the 2.3, and this is our original Kickstarter. Now this original Kickstarter raised $111,000, and that's how OpenROV got started. If it weren't for this Kickstarter, I probably wouldn't have a job right now. Another important thing to mention about the OpenROV technology that's been consistent throughout all the designs is the hacked home plug adapters that we use to communicate through the tether. Now one of the challenges that we faced at the beginning of the project was how we want to go deep. We want to take these things deep down where people cannot go to look at what's down there. And so communicating through USB, through other tethers, it was expensive to get all that wire. It was expensive to communicate through a USB at the time. It was difficult to do. So what we found out is that, is anyone familiar with Tenda technology, home plug adapter technology? This particular technology it's just kind of an innocuous, no one really pays much attention to it. It's something that was designed to run a wired LAN through your house, through the electrical system. What you would do is take two paired adapters. You can plug one into that outlet, hook it into your network, take another Tenda adapter, plug it anywhere in this building that's on the same electrical grid, and it will run the internet through that voltage signal to that outlet, and you can run a hardwired signal that way. One of the people that was on our forums, named Walt Holm, one day posted on the forum, why don't you guys use these Tenda adapters to run the internet protocol down the tether? And lo and behold, it worked. In fact, it works way past 100 meters. You can actually run internet through a wire, I think it's close to 500 meters of tether before you start to have a degradation in the internet signal. So what you're going to find in all these, hacked into these electronics is a Tenda home plug adapter that connects to the tether, which then runs a LAN connection into the BeagleBone. That goes up the tether into a topside, another Tenda adapter that you can then connect to your laptop and create a local area network between your laptop and the robot. And that's the key to making these things work at the depths that we get them to go to effectively. The next design iteration of the OpenROV is the 2.6. I'll bring it out and set it next to the 2.3. Now, what you're going to notice, if you saw in the video, the propellers on the back of the ROV in my video were boat propellers. They weren't even marine propellers. So when I had that thing in the water in Utah, the propellers spinned, but it kind of just went meh. You see, it really didn't go very fast. I didn't have much vertical control. One of the first things that I did when I got to OpenROV, they had just come out with this new version, the 2.6. One of the big changes on it were marine props. These props have left-hand and right-hand configurations, and they really shoot the water out. So this was a big improvement with the 2.6. A lot of the things are the same. You'll see the camera. We're able to develop an internally developed controller board, which is an Arduino unit that helps control the servo, motors, all the rest of that. And the big change in this one is this one would go.
Can you show the props to the camera?
What's that?
Can you show the props to the camera?
Yes. Go ahead.
Maybe if you go like hold one up, hold them both up so we can see the difference on the camera.
Well, the first thing I did to this unit when I got to the lab was change the props out. If you saw because it just wouldn't move. That was one of the problems. Like it would go in the water, the props spun, but it just would beep, 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 beep.
Yeah.
As soon as I put these props on, the thing would start moving through the water really effectively. The vertical prop, same thing. This thing will shoot down in the water and move. This was a big improvement. Another improvement was the O-ring seals. You see these O-ring seals. This is another key to making these things work. In the beginning prototypes, these tubes that we would order, sometimes the tolerances on the internal diameters wouldn't be quite right because of quality control with our O-ring seals. So a lot of these first units just leaked. They were called a proof of concept. I got really lucky with this version in that the tube that I happened to get fit perfectly on this O-ring, so luckily mine didn't leak. The newer versions had better tubes and a bigger O-ring. So these versions either didn't leak at all or had minimal leaking issues that could be mitigated with plumber's tape or a little extra engineering gusto, as I like to say. So that was a major improvement from the 2.3 to the 2.6. Props, better O-rings, and a proprietary controller board that Walt Home, the guy who came up with the idea for the 10 to home plug adapters, actually designs our circuit boards now. He's our lead engineer. If you see on the slide, this is the 2.6. What was nice too about these laser cut acrylic parts, these are home built robots. And since it's open source, you can do whatever you want. You can make it in blue acrylic. You can have your little logo etched on the side. You can make it pink. You can essentially cut the parts and make it however you wanted, since it was open source. And we encourage people, at OpenROV, we encourage people to download our plans off the internet, download the code, and do whatever you want with it. It's a lot of fun. When I started at OpenROV, the 2.6 had just been released. And they were working, our R&D department was working on the 2.7. Now, in my opinion, and a lot of people's opinion, this is where OpenROV took a great leap forward. From the 2.6 to the 2.7, there were a number of improvements. I'll pull out the 2.7. This 2.7 was at Maker Faire and actually won a Editor's Choice Award. Now, it had a better hydrodynamically designed shell. You notice the props are going to be the same. We got DST 700 motors on this one. These motors are I'm not sure exactly how much more efficient they are. They're way more efficient than these motors that we had on these. They were faster, they're more reliable. These things, if you maintain them with a little WD-40 silicone, will just keep going and going and going without replacement.
So they don't even, they're okay in seawater too?
What I like to tell people is when they use these in seawater, how many divers do we have out here that like to scuba dive? What do you do with your dive equipment as soon as you get out of the water?
Rinse it off.
It's exactly what you want to do with these. If you follow that post-dive maintenance with the ROV, you'll have very little maintenance issues.
And the brushless hub motors work fine in water?
Yeah, they do. I've actually built close to 200 of these by now, and I test them in the ocean all the time. And as long as you've built them correctly and you maintain them, I've had my favorite robot is the 2.7 right now. It's one of the first ones I built that was my robot that I built at OpenROV. I got to watch the development of it, and it's when I first was hired as lead technician at OpenROV. And we just started cranking these out. People were buying them like, everyone wanted one. And so it was so much fun to build these and get them out into the world. The 2.7 also switched to the BeagleBone Black controller. It's a little bit more efficient. It was cheaper. For some reason, everything gets cheaper and better when it comes to electronics, which is always nice. But what you'll notice is we have the exact same camera in that. Now, we modified it a little bit so it will fit. We got a light bar that actually connects to things a lot easier rather than having to solder those LEDs on. Something else to mention about each iteration of the OpenROV is that we've tried to make it easier to build each time. This first one took me a year to build. Getting the parts was difficult. It required lots and lots of soldering. It required lots of troubleshooting. It kind of leaked. So this version got a little bit easier to build. This version was even easier to build. And what's nice about that is when schools buy them and people, what we like to do is advertise that, anyone can build one of these. And with some patience and understanding, I believe that that's true. And each version does get easier and easier to build. They're put together from acrylic parts that we put together with acrylic glue. I'm amazed at how well they come together for something that someone can build themselves. You wouldn't think that just an ordinary person could build an actual ROV that could go 100 meters under the water. But with OpenROV, that's entirely possible.
you have a special jig to heat and bend the core?
Yes, we actually have a strip heater. And these polypro are cut on a laser cutter. It's highly toxic. We have a special filter that we use in a laser cutter whenever we put these polypropylene sheets on there to cut these shells. It actually cuts a small little etching in the side there. We put it on the strip heater, about 50 seconds, bend it down. Another improvement from the 2.6 to the 2.7 is battery tubes. These battery tubes have better O-rings, better straps to hold them on. Makes things a little bit easier. These, you would have to just cut these off and put new ones on each time, and the plastic usually just ended up on the floor or in the trash can. These are reusable straps you can pull off, get your batteries out a little bit easier. But, you know, some people thought this was kind of janky and hard to deal with. These were the first 4 2.7s that I ever built. And Vincent and old Bob are still going today after over a year of runtime. These two, I'm not even sure where they are. This is the 2.8. This is the version that we've just developed for the 2 series. Now, what I like about the 2.8 is no more straps, no more weird battery tubes. These twist, caps come right off. Do a quick battery change that way. One of our talented young engineers, J.R. Wong, he came up with this design for the battery tube end caps. Now something like this you just think is real simple and easy, but it makes all the difference when you're in the field and you're having to change batteries, and you know, it's just one less thing you have to worry about. I'm trying to think what's still the same on this version. The motors are the same, the propellers are the same, as you can see. Some of the hydrodynamics on the tube has changed. This particular tube is a 3/16" tube, as opposed to a much thinner tube here. The depth rating on this one is over 100 meters. We have not tested it yet to see exactly how deep it will go. I believe it could go 150 meters plus with this thicker tube. I was testing a prototype of a deep unit, and I got it to go to 180 meters. Now, since we haven't actually tested it, we still like to say 100 meters, but I have a hunch that this one is going to beat 100 meters significantly. So that's one of the improvements on the 2.8. It still uses an Arduino controller board with a BeagleBone Black. The camera is a little easier to install. I would say this is probably about 20% easier to build.
What kind of batteries do you use?
They are lithium-ion 3.2 volt cells. They're rechargeable. Another good thing about the open source project OpenROV, any question I can't answer tonight, you can go online to GitHub, you can go to our forums, you can go to the online resources and find out everything you want to know about these things. This is the one that we're going to be connecting later. If anyone wants to join me, we're going to try to throw it in the fountain out here and see if we can get it to go.
Excellent.
But recently we tested the 2.8s at the Soda Aquatic Center, and it was a lot of fun. We just threw these things in the water and just started flying them around and running into each other and having fights. We actually did what I call the Luke Skywalker maneuver from Empire Strikes Back. One of my coworkers' ROVs was kind of stalled in the water. I flew mine around several times, tied my tether around his, and just yanked him across the pool. He wasn't too happy about it, but it was absolutely hilarious.
Does it have, you mentioned drones earlier, aerial drones have some kind of stability programming so keep them stable in the water. Does the OpenROV have a similar stability?
That's something that we're working on. The first plugin that we had for stability kind of actually would move the camera based on the tilt. However, the latency just made the camera stick sideways and stick there. And so there's some bugs that we need to work out on that one.
And what's the battery life? I guess it depends on how much you use it. But
exactly. Each one of these units has a thrust factor from 1 to 5. Typically, I like to put it on 3 for just general use. If you put it on 4 or 5, it's good for getting out of snags. I like to call it, if you've ever driven a 4-wheel drive and you get stuck, you move back and forth. Whenever if I get stuck on something, I'll put it on 4 or 5 and just start moving back and forth to see if I can swim out of whatever I've been hung up in. So far, I've been able to do that and get out of a lot of messes with these things. Sometimes not, and I have to dive in the water and go get it. So depending on how hard you run the lights, the motors, the servos inside it, the battery life can be anywhere from 1 hour to 4 to 5 hours. And that brings us to the next and final, I'm not even going to say the final version because I don't know how long this is going to go. Because we keep coming out with new robots and each one gets better than the last. So this is the one probably everyone wants to see. This is what we call the Trident. This is one of the first prototypes of the Trident. Now you're going to notice this one looks nothing like any of these. It's a different model, it has a different capability, and it's just a whole different robot than the 2 Series. The 2 Series is more of a dive down, kind of hover about, look at this and that, turn a little bit this way, turn a little bit this way, maybe look down. It's kind of slow, it's kind of bouncy. Sometimes there's lots of currents, maybe a little hard to control. I mean, in the pool, it's kind of optimal because you can go up and down, easy to control. You put this thing in a river or an ocean current, not so much. This thing moves. This thing on 2 moves faster than any of these units. Now, if you look at the bottom of this unit, it's cleared out so you can kind of see what we have in there. In that little box, you're going to find some of the same electronics that are inside this. They're just configured in a different way. And this particular one uses 2 servos to control these ailerons in the back, and the propellers have already fallen off of this one. But it shoots the water through these, what we call court nozzles, and these ailerons will then focus the water in different directions to make it move. Now when we hook this thing up, it kind of causes a little bit of, what's the word, motion sickness when you're looking at the screen. It moves so fast. I think we said, I'm trying to remember how fast it goes, maybe 5 knots. But when you see it in the water, in the Kickstarter video, this thing just shoots. And we've been working on Oculus Rift control for it. You can put your gamepad, hook it up, put it in the water, throw it right in the water, and it goes. And you're going to see in the video, it can shoot out of the water like a manta ray and right back down.
Awesome.
And that's tethered too.
Yes, it's still tethered. I'll speak a little bit about how we're going to try to hope to get rid of the tether. Everyone tells me it's a pipe dream, but I think it could happen with the right group of engineers in the right room, all working hard on it.
The U.S. government has done it quite fine.
What's that?
The U.S. government does it quite fine. It takes really powerful green lasers.
Really? Okay, green lasers. I've also heard that like submarines have to come up a little bit before they can actually start communicating.
There's still a limit.
Yeah.
They're very, very low bandwidth, very low RF.
Yeah,
like,
the ELF.
That's the sort of thing I love to hear about. If anyone wants to get me, contact me and talk about.
Forget like 300 baud, forget like 9600 baud or even 300 baud.
Right.
Yeah,
Not even like the lowest modem speeds.
Talk to me later. About a year ago, I spent a lot of time digging into the academic research on RF underwater.
I've been looking at acoustics. I know that I've studied whales my whole life, just armchair marine biologist.
Mm-hmm.
And I know that whales can talk miles and miles and miles just by singing songs to one another. And so my thought is to have these things start to sing songs for one another. One of my first hacks when I got my ROV was to put a DR15 digital recorder in it and put a hydrophone on it so we could put it in the water and start listening to stuff. And that's something I plan on continuing to do.
Have you heard anything?
Boat motors. And a mysterious beeping that we're not sure what it is. It was in the Berkeley Marina. If we have time, I can actually play the recording. I've got it up on SoundCloud. So let's watch the latest Kickstarter video for what we call the Trident.
Hey, I'm David. And I'm Eric. And 3 years ago, we came to you, Kickstarter, and told you about our dream to make a low-cost underwater robot. We want to make underwater exploration accessible to everybody. A lot has happened in the past 3 years. We've shipped thousands of these robots to 50 countries, every continent.
They made us wear those dumb hats.
More than we until this meeting. So for the last 3 years, we've been working on how to make underwater exploration tools the right way. And what we've come up with is something we're extremely excited to announce. This is the Trident.
Right, that's what I said.
We believe that exploration is not just about gathering data, but also about experiencing new worlds in a new way. We've designed Trident to be extremely fun to fly. Most ROVs, they move up and down slowly, they go left and right, forward, reverse. Trident is nothing like that. It flies like an airplane. It speeds along, you can bank, you can dive. It's fun to fly. It goes fast when you want it to, but it can slow down and be precise when you have something you want to inspect. Getting video from underwater has always been a challenge because radio waves don't travel through water. So we've developed a very lightweight, neutrally buoyant tether, which communicates the video feed from the ROV up to the surface. That attaches to a wireless buoy, which allows you to control the ROV from any Wi-Fi connected device. A tablet, a laptop, or even a VR device like an Oculus Rift or a Google Car. We wanted an ROV that could go to places that no ROV had been before. So we designed it to be ultra portable, whether you're hiking to high alpine lakes or you're bringing this as carry-on luggage. It goes wherever you go. Most ROVs are designed to look in specific places where you already know where the target is, but we realized that a lot of people want to explore with an ROV. We designed Trident to be extremely hydrodynamic and excellent at going in long, straight lines. This allows you to do lawnmower patterns, being able to broadly explore places you've never seen before and find out what's there. We've seen community members take this model and create 3D visualizations of the seafloor. Using technologies like photogrammetry and structure for motion, we hope that we can help create maps of the underwater world that will allow us to see it completely different. I joined this project when it was the initial Kickstarter, and I did it because it was going to be a chance to take this hardware, robots, and I was going to be able to use my software skills to actually program them and have them use that underwater. I've been using that to build a platform now that lets other software geeks like myself contribute and help programmers find ways to control robots. We made a plug-in architecture that allows you to add your own components, add new sensors, new technology to the ROV after it's already been developed and out in the field. The OpenROV software, it's bigger than any single ROV. It's opening the door to services and technologies that we're just not ready.
Now, what's interesting, what I like to point out in this video is that when I was in Missouri and I first saw this project on the Boing Boing, it never occurred to me in a million years that I would be working for OpenROV someday, and the robot I built would actually be in the background of this Kickstarter video. Because it's actually, this is considered a museum piece at our lab right now.
Yeah, that's awesome.
I'm considered a museum piece.
To imaging beaches and underwater shipwrecks in 3D. We're going to be able to send this data and utilize cloud computing and mesh networking and all kinds of future technologies to make it available to everybody. So whether you're a fisherman, a researcher, a recreational boater, or just someone who's curious about what's below the surface, this is the tool for you. So here we are. We've spent the last 4 years developing underwater robots, and we've never been more excited about the project we have now. To get to the next level, to bring Trident to life, we need your help. So check out the reward levels, let us know what you think, and together, let's build the future of underwater exploration. Thank you.
Thanks so much. And another thing that's just absolutely amazing is if you look at the dollar amount we've raised so far with 30 days to go, we've almost, by 6 times, beat our original funding that we got for the first 2-3 series.
What was your stretch? What was your stretch goal?
50,000. Which there was some sort of logic behind that. We definitely wanted to hit the goal. David Lang is an expert in setting up these Kickstarters. So he definitely knows what he's doing when he set this up because the dollar amount speaks for itself.
How much is the Trident doing?
The Trident right now, if you'd gotten an early bird special on the Kickstarter, we were doing it for I think $700, $699. When they retail, they're going to be $1,200, which is about the price point of what the 2 series was. So not only are you going to get a much better flying ROV, it's about the same price as the original version. Now the difference is going to be, personally, I have a fond I'm fond of these 2 Series robots. They're kits, they're do-it-yourself kits. Most of what we sell at OpenROV is a box with the parts that you need to make the robot. And so, for me, building this robot was an engineering degree. It took me a year to build it, but I learned so much about Arduinos, BeagleBones, programming, JavaScript, how to SSH into a robot, things that I hadn't thought about since I had a Commodore 64.
You can SSH on a Commodore 64.
No. But I mean, does anyone remember Compute's Gazette, one of the first computer magazines?
Yeah.
And you could type the programs
Yeah.
in the back, and
Yeah.
that's what I did on my Commodore 64. I would sit there and spend like a whole weekend putting this machine language code in. I had no idea what it did, so I could, hit sharks with a boat paddle.
Yeah.
Or play some Pac-Man knockoff.
Question. You said this is all open source.
Yes.
Do you sell just partial kits, for example, and let people source their own electronics?
We absolutely do. We have a store that's set up where you can buy any or all the parts that you want. You can get your own parts to mod. We encourage that. So.
And the other question is, since you're dealing with people that really have the same interest at heart that you do, you're using your parts, especially the proprietary stuff, is there any symbiotic relationship between you and your customers?
Absolutely.
If they develop code?
Absolutely. We call it a community. If you go to our forums and study our project, it's really a close-knit group of people that go to the forums, have the similar interests, and that's how I got hired at OpenROV. That's how Walt Holm got on at OpenROV. We became part of the community before we actually became employees. So I was always on the forums and going to the Google chats for the whole time I was building this thing. And what I like to say, what was great about the OpenROV project is no matter who you were or where you got in on the project, if you go on those forums, you had people helping you that worked for NASA, that worked for Boeing, people that have degrees from Carnegie Mellon, some of the finest engineering schools in the world have all worked on this project. And anyone that joined that community had all of that knowledge at their disposal. And anyone on those forums is most helpful when you have a build problem, if you have a programming question, if you have a specific engineering question, if you want to know about depth pressures and what happens to things at certain depths. We do pressure testing in the lab. We do implosions. If anyone's seen an implosion, it's one of the greatest things in the world to watch. It's the opposite of an explosion. A lot of energy when thousands and thousands of pounds of water all focus in on one little spot. So what I spoke about in the beginning, I kind of went ahead of my slides a little bit because I was excited. Rapid iteration is how these robots actually came together the way they did. Again, the CAD software, Autodesk, Onshape is now an open, I think it's an open source CAD software that anyone can get and use.
It's not open.
It's not open source? Is it free?
Currently freely available.
It's freely available.
But it's probably going to change.
When I started with the 2.3, Autodesk was $7,000 for a license, and I thought I'm going to use this for 14 days, but that's probably going to be it. Now that Onshape's out, and that's actually what we've used to design the Trident is Onshape, which is a free CAD software.
Yeah, the advantage with Onshape is it looks like they're going to be like $100 a month, but with none of these yearly contract things. So you can work on something for a month, let it go, whatever.
And $100 a month, that's
better than
that's about what I pay for this presentation software.
right.
Okay, I'm going to talk about the hardware and software a little bit, and I'm just going to go down the list here. If anyone has any questions and they want to get more specific, feel free to contact me after this presentation, and or go to our website and you can be referred to one of the experts that works for us that actually has designed some of this or written some of this programming. We have an Arduino controller board that's currently internally developed. We used to use a BeagleBone cape for the controller, but we discovered, and plus we hired Walt Holm, who's an excellent engineer who worked for the aircraft industry, and he's like, I can design boards all day long, let's make our own board. And so that is exactly what we did. The Arduino does voltage regulation, and it also helps with the ESC's electronic speed controllers. The firmware on that Arduino is C++. The BeagleBone Black uses a Flash image, and it also uses JavaScript Node.js. I assume most of you know what Node.js is. I just kind of learned. It's a input-output application programming interface that allows for server-side scripting, and I guess you get less errors and bugs when you're using Node.js. I believe that Node.js is programmed in C++, but it enables you to work in JavaScript. And one thing I have learned to do is I've become familiar with the file libraries on the ROV. If any of you would like to, you can SSH into any one of these robots and take a look at the file libraries. And what I like to do, since I'm not an expert programmer, but I kind of know what I want to work on, one of the first things I did programming-wise on these robots was the gamepad controller. Currently, you can plug an Xbox wired USB gamepad controller into your laptop. As long as you have the right updates to your Chrome, you can fly these with just a over-the-counter gamepad controller. The thing is, you may not like what the buttons do, because that's, the person that programmed this, they assigned the buttons to do certain things. You push forward, the motors go forward, you press the B button, maybe the server goes up and down. The first thing I wanted to do was to customize that based on my own whims. So the first thing that Brian Adams taught me to do was a grep-r command, so I could find the files I was looking for to manipulate what I wanted to manipulate. And what I discovered is this what was called a pilot file that had all the gamepad controls. And I could change lights turning on to this button. So one of the first things I learned was just to completely mismatch all the controls to do what I wanted them to do. Personally, I liked the red button to be the lasers because the lasers are red. And I wanted the yellow button to be the lights because the lights are yellow. I also wanted to put the servo control for the camera on the D-pad controller so that it was easy to move up and down. Sometimes I like to put tank controls on it, so when you pull the triggers, it would run the motors. Or given that programming architecture, it enabled me to basically manipulate those controls however I wanted to do. And so that's a fun thing to do. If you end up working on some of the programming and you just want to find certain JavaScript files and start playing around with them to see what they'll do, it's a really easy process to do. I was able to do it, and I hadn't programmed in almost 20 years. Now, I spoke about the 10-to-home plug adapters already. It's a hacked consumer product. It uses a 3.3 volt carrier through the twisted pair tether to communicate that LAN signal. And again, the laptop that you have uses a URL to communicate with the BeagleBone. Creates a link between the two, and that's how you get control, you get internet, you get your cockpit, you get your webcam, you get everything you want to see. Another piece of electronics that we've developed internally is our inertial measurement unit. Now, some of you might want to try this unit out on your land robots. It provides a magnetometer, which if you calibrate it, it will eventually find north and hold that position. It has pitch and yaw on it. It also has depth. I'm not sure why you'd want depth on a land unit, but perhaps if the barometer changes, you could it would help with that a little bit. You might know if rain is coming. So the team. These guys are my heroes. If it weren't for them and this project they created, I would probably still be sitting in a beige cube, being vice president of something, in some office, with more money than brains.
Counting seeds.
At Bunge North America, I literally counted beans. They're an oilseed processing company. So imagine the jokes that I had to put up with. You guys probably have all seen Eric Stackpole in some of the maker fairs. He's the genius behind it all. He designed this robot. He started building it in his garage, and it led to him becoming the darling of the maker fair movement. David Lane comes along and meets Eric Stackpole. He decides he wants to start an underwater robot company too, and writes a book called Zero to Maker about how just about anyone can become a robot maker if they really want to. David was a member of the tech shop. He took a lot of classes there, and he's been a real proponent of the maker movement. And this book is something I read that gave me the inspiration to come out here and do what I did. There's Walt sitting there with his hand on his face. He's another one of my heroes. He's one of the engineers that made all this technology come together and work properly. And if it weren't for just the right people in the right room at the right time, this would not be where it was right now. This is the last hackathon that we had. What we did, what we discovered over like maybe a year of building these robots, we had about 6 shells of junked robots. And one day I started looking at them and thought, well, you know, if we took this part from this one and this part from this one, we could probably make about 8 or 9 robots out of all this. Whoops. I bumped it. There we go. So what we did, we had the community come in, and we just let them take our junk pile and make whatever they wanted. Some people made robots, some people made boats. You can see one in the background. This guy, Jaime, he lives in Berkeley. If you look at this robot right here, this is one he made with our technology, but he just used all his own like hardware pieces. And when you see what this guy makes in his kitchen, he doesn't actually have a workshop. He has a 1-room apartment and a kitchen, and he makes some of the best ROVs I've ever seen. They're works of art. I wish I could have brought one of his. Jaime is actually just the epitome of what our community is like. He's taken our technology and just built something totally different with it that's just beautiful. I think the top of that robot is made from an old laptop metal, and he actually cut it out with a saw, uses a piece of sandpaper to polish it. And when you look at this, it looks like something that NASA built. And he made it in his kitchen. But this is our lab. This is a good example of our community and the kind of things we like to do. I just want to say thanks for everyone's support. And of course, never stop exploring. And I open the floor to questions, or if anyone would like, I can hook up a robot and we can see what it sees. I also have some YouTube videos of some of the things we've done with the robots. We found a wheelchair at the bottom of the Berkeley Marina, which is a fun little video to watch. We recently visited Hester Lake, where we found a B-24 bomber that had crashed into that lake.
Wow.
And we have a lot of, someone brought in a robot with a robot arm. What I'd like to do is go to my YouTube page and show you one of our latest community hacks is we've developed an underwater servo that's filled with mineral oil. And it will actually run a underwater gripper arm at 100 meters. This is one of our first tests of it. This claw can actually go down and pick up a GoPro. This is a view from the cockpit. Now, as you can see, I think we had a little bit of fog on the camera that day, but you're going to get to see it from both perspectives, the perspective of the robot and then the perspective of the actual GoPro. So we had the GoPro on while we were rescuing the GoPro.
How's the artificial horizon being generated?
That's part of the inertial measurement unit. So if that thing's positioned perfectly, it's going to be a straight line, and as the robot moves this way and this way, it's going to show that pitch and yaw on the screen. It's not always 100% accurate. And also, if you mount mount the IMU tilted, when you have it straight, it's going to be tilted. It actually picked up, that was our first test of it, to actually pick something up with that claw.
What sort of lift capacity would a robot have?
Not very much. It would be good for maybe attaching a hook to something that had a better lift capacity that you could then, once you use the ROV to attach the hook, you can let go of that hook and then pull it up. Now here's the view from the GoPro. This is a much better shot. You can see the robot coming down with the arm in the front. And I think we attached this thing to that with rubber bands and a piece of plastic just to get it on there.
If I was a shrimp.
Yeah. That's a good one.
Is that the condensation on the inside of the tube?
That was, that particular day, we didn't really do what we were supposed to do on the O-ring seals, and we were more interested in the servo, so we had a little condensation on the side of the thing. Are we about done on time?
Let's take some questions now.
Okay, sure.
Got a question, right?
Yeah, go ahead.
Why don't you pass power along the tether, and what happens when the tether gets permanently hung on an underwater obstruction?
We've had some community members actually run power through the tether. Some of the issues you face is maybe I think the wire needs to be thicker to run a good voltage through it, and then once you start doing that, the current, if you look at this tether, it's almost precisely weighted and has precisely the amount of wire that we need. If we get thicker wire, the thing just starts sinking to the bottom, makes the robot sink. Thinner wire, if you try to pull on it, it breaks. This is almost the exact.
Was it 20 gauge?
I think it's 20 gauge, and it'll pull about 25 pounds. I've actually had a 2.7 hung up on a log, and I just yanked, and started yanking, and it pulled up a big branch about the size of this table, about that big around.
So when, assuming you couldn't pull that branch up, is there a way for the ROV to disconnect from the tether and surface?
Interesting you say that. We now have a detachable tether that you can actually unscrew if you needed to, but if you go online and see some of the videos of people getting themselves untangled, it mostly just requires creative piloting. I've seen people actually, what they'll do is they'll kind of fly out, turn around and look at the snag, and then figure out maybe I need to fly way over here and go this way and then pull myself out. I've done that several times. I've only had to go diving for one once. And we've actually, the people that work there, we've only lost one that we actually were able to go back and find later.
Yeah, wasn't the original home plug run at something like 300 baud?
Yeah, I think the first home plugs weren't that robust. I know the ones we use now, we get pretty good latency through them, and it runs that land through that quite effectively through that tether. And
what grade? Baud rate?
That's a good question. I don't know the answer to that.
Well, I was thinking, you know, if you're like someone over here suggested, if you ran a relatively low voltage AC, the home plug was designed to run.
Mm-hmm.
On an AC, I think they sent most of the messages at zero crossing or something like that. So those communications devices would be compatible with running, say, 48 volt to 24 volt AC, and then just rectify it at the other end. That way you wouldn't have to have all those batteries and last a long time.
That's true. We thought about trying that too. Another thing that's nice about the batteries with this current design, they provide the weight that's needed to make it neutrally buoyant. Without the batteries, we'd have to add a bunch of lead weight anyway. And what we've discovered as well, most consumers, people that like to run these things, people like myself, after about 4 hours, I'm kind of ready to go home. So, I mean, we haven't had many issues with that. And, you know, I would encourage anyone that wants to try to do what we've talked about, running power through the tether. The newer version, Trident, we're actually, since the batteries are kind of going to be in there and closed down, and they're not going to be designed for you to get to that often, we're going to actually try to be charging those through the wire.
A second question. You're using the BeagleBone Black, which I think has 100 megahertz Ethernet built into it.
Mm-hmm.
Why wouldn't you use Ethernet for communications?
I think we actually are using Ethernet. It actually.
Well, I thought you said you were running the home plug communication.
Unless I'm mistaken, it runs an Ethernet. It runs an Ethernet signal through the tether.
Okay.
At least that's what we call it.
Ethernet.
I may have my terminology wrong, but a local area connection, Ethernet is what we call it. We have an Ethernet jumper in there that communicates from the Beagle Bone to the home plug. And that home plug is actually connected to the tether.
With the right quality wire, there's nothing that would stop you from doing Ethernet framing over, I mean, because like if you look at like pairing, it's actually really only 2 pairs that you use for data. The rest you use for ground and signaling.
Yeah, but
this is how you're able to do PoE.
It's a pretty long wire though, right? I mean,
yeah, I mean, if you're, that's the other thing, if you're going to do 100 meters, then you're kind of bumping up against that.
Is your name Steve?
Yes.
I know Steve from the tech shop.
Yeah, I thought I recognized
We had a hack day there, and he helped me pull off just a genius hack. I didn't tell you guys this about me, but I play keyboards and synthesizer, and I've worked with MIDI a lot when I was a musician.
Oh, that's right. Yeah, I remember that.
Steve helped me actually connect a keyboard to the OpenROV, and we were making the lights and motors go by playing the keyboard. And no one believed we could. Do you remember that day? Everyone's like, that'll never work. That's dumb. That'll never work. And then the next thing we know, we had that thing going, and everyone had to shut up. It was awesome.
That was fun.
I just knew from my keyboard days how MIDI worked, and I thought, yeah, surely we can make that work. And then you guys came along and made it work.
I do have a question about the home plug. You said that this is like a hacks consumer technology.
Yeah.
I know that it was in Fry's. It was kind of out there like about 10 years ago and never really went anywhere. I think because Ethernet itself, the RJ45, just suddenly became like really, really cheap. And so,
and
as a consumer thing, it just never went.
I mean,
but so because of that, are you making your own devices, or are you
that's where we're headed, I think.
A stockpile? Did you go off and buy like all of
the above, Steve? Actually, that's all of the above. If you saw our warehouse, how many boxes of these tendons we have, we buy them in bulk, and we buy a lot of them because we were worried exactly about what you were going to say, that they were going to stop making them, and then suddenly we got no product, or we have to have a lot of NRE. A non-recurring engineering cost to come up with our own design. But that's kind of where we're headed with it. We're hoping to design our own Tenda adapters that communicate that protocol. Something else that's exciting about Tenda that's coming up, and has anyone seen their wireless home plug adapters? One of the great things about Trident is that we've developed a topside buoy that has a wireless Tenda adapter in it. So the wire goes up to a buoy. The buoy has a little antenna on it. Now I've tested this at about 50 meters from shore. Now this is where it can be kind of wireless. You throw the ROV in that buoy into the lake or the water. Your laptop controls through its wireless adapter to that buoy, and you can sit there and control the robot without any wire from your computer to the water. The only concern there is if current picks up or the wind picks up or you don't have a buddy to go swimming for it, you lose control of the robot, that you just go floating away. But it's recoverable. You get in a boat, as long as that buoy stays there, you could find the robot.
Somebody back there who had, yeah, you.
Oh yeah, what was the operating system for?
Probably Linux.
The OS, yeah, I think it is Linux. I mean, the OS to me is the cockpit. It's a web server that we developed, and I believe it's all programmed in JavaScript. The OS, I guess, could be considered Chrome, Google Chrome. Feel free to correct me.
Oh, like, is there a specific version of Linux that the bot is using?
No, I don't know. I don't know. If you go online, we should be able to answer those questions online on the forums.
Next time's over there.
I had a question about, you showed a section about mapping underwater, and doing like 3D mapping.
Yes.
How are you guys doing that? Or can you talk more about your mapping efforts and maybe controlling with the kind of heads-up display or some sort of Oculus project? I just want to hear more about that.
I'll be glad to talk about that.
Yeah.
But what we've been doing lately is we've been experimenting with GoPro cameras, multiple GoPro cameras on the units that are actually taking like a bunch of pictures as the thing goes by, and we call it form to motion, picture to motion, I think is what it's called. And we've been experimenting with those, with doing that. The problem that we've had with these 2 series robots, though, is that they're meant to dive down and look at things and move around. They're not meant to move in a straight line really fast to get the transect that you need to get that kind of data. With the Trident, that's going to be possible. We've experimented with, again, you just using GoPros, cameras that have a high frame rate is what's needed to make that happen. We've also experimented with low-cost sonar devices that might be helpful with that sort of thing. That's kind of where it's headed. Just last night, one of our programmers developed an Oculus Rift interface for the OpenROV. And the thing actually, I don't know if anyone's used Oculus Rift yet, the thing just blew my mind. When I put this Oculus Rift on, suddenly I was like in the cockpit of a spaceship. And there were bulkheads, and there were little things I could touch with my hand, like from Minority Report. And he's actually getting this so that the camera of the ROV will be up on that. When you put the Oculus Rift device on, suddenly, I mean, that just opens the floodgates. You could be inside a submarine, you could be inside a spaceship, and see what the ROV sees. And is anyone planning to go to East Bay Mini Maker Faire? What we're hoping to showcase at that Maker Faire is we're going to take a 2 series. We're going to have the camera on the front, we're going to put 2 more cameras on the side, and we're going to interface it with the Oculus Rift for the first time so that when you look this way and you look that way, it's going to use all the cameras to give you a view of maybe not 360 degrees yet, but 180. And I can't wait to try that out.
Do we have any further questions?
Could we go back to the goal or to the?
Sure. Just real quick, I want to show you this wheelchair rescue because it's considered the first.
Can I ask one question?
Yes.
How do you seal the connection to the into the electronics? Is it just epoxy?
Yes, it's potted. I'll go ahead and show you how we do that. I'll take this one apart. Another great thing about these things is how easy they come apart. Now, if anyone would like, they can feel free to come up and take a look at these electronics. They're connected by a DB25 that connects in here. The whole thing, I build these things all day, so I love taking them apart and putting them together. You'd be amazed how easy the whole thing comes apart. You can see each component of the ROV. This RJ45 jumper will come out. Let's just yank this right off here.
But how do you get the wire through the water barrier?
The question was the water barrier.
Right. These end caps are made from several pieces of acrylic that are acrylic glued together, and it makes it thick enough to withstand those pressures if it's glued properly. Now, you'll notice some little holes that go through the side. When you build this, you take your wiring harness, you put it through this hole up through the top, and then you fill it with epoxy and pot it. Let it sit overnight, and you've got a waterproof seal through there. These O-rings fit on a gland inside the end cap, and that's what keeps the water out. It creates a watertight seal between the tube itself. You can actually see it if you get up close where that ring is, and the inside of the gland. Very similar to how, has anyone played with an iPhone underwater case? If anyone has one of those, you'll notice a little O-ring on the side. If anyone uses scuba equipment, the O-ring in many cases is the thing that saves your life under the water, makes everything work. That's what keeps most of the water. We're going to have
to start.
There's one question over here.
Oh,
go ahead.
The roboticist and the
yes. Feel free.
Okay.
I remember you were calling something about a fair, like a Maker Faire or something like
yes.
that. What is that?
Maker Faire is a festival for people that like to make things. So I would definitely ask your mother and father to take you to a Maker Faire. It's going to be the coolest thing you've ever done. There's going to be people with robots everywhere, of every shape, kind, and description. People that make things out of wood, out of metal. I can't believe it every time I go what I'm going to see.
Okay. I know there's a few more questions, but what we need to do is sort of shut down here. Come on up and ask them questions. And if you don't ask them too many questions, maybe haul it out to the fountain and dump it in.
Sure.
Okay? So thank you very much. Okay. One last request. See that box on the chair there? Please drop your badges in there as you're rolling out of the joint here. Thank you very much, and hopefully we'll see you next month for our 13th Tabletop Challenge. Phase 3. Thank you very much.